Good morning, children. Today we are going to start new chapter 11, constructions. To construct a bisector of a given angle, that means angle bisector we have to construct. So given angle ABC at any measurement, this is a general way of constructing angle bisector. I am telling, later we can go for the measurement wise. So angle ABC, any measurement we can take. What is the steps of the construction means? Roughly I will draw here. That is angle ABC is given. So A, B, C. Next, B as a center. At any radius, you have to draw an arc here with the help of the compass. It intersect BA at E and BC at D. So you will get an arc of the circle like this. Now, with the D and E as a center, we have to draw two more arcs. That is more than half of this one. So it will be bisected equally. That is a sentence. It is written here. What is the first step? Taking angle ABC is given. Taking B as a center and any radius, draw an arc. So roughly I have shown you here. That is, it is cutting at D and E. So D is the arc. Now what is the next step? D and E as a center. More than half of D, we have to draw an arc which intersect at F. Now BF is the required angle bisector. That means whatever angle is here, it will be bisected equally. Let us see the construction now. We have got the three steps now. Let us see the construction. So what is given to you? An angle is given, that is angle ABC. Now what is the next step? With B as a center and any radius, convenient radius you can take. So we are keeping here B and drawing an arc, any radius. So here I'll draw an arc like this. Okay, now the radius I cannot change now. So here, what is the point we are getting? It is D. According to the statement I am marking here, it is E. So D and E we got. Now already we have to take already B as a center, we have drawn the arc. Now D and E as a center. Just check that the same radius is possible because more than half of D required. What is required? More than half of D. So already it is more than half. So the same radius I am keeping, and with the D as a center I have drawn the arc. Now E as a center we have drawn the arc. Now it is intersecting at which point? F. Okay, now with the help of the scale we can draw BF. So BF is the required angle, sorry, required ray. So I completed BF now. Completing BF. It's a ray. So BF is the required ray for this one. So once again I'll draw the diagram. Any angle it is given. So let us take any angle. What is the steps? One more time I'm showing. So any angle, draw it. We are not taking any measurement here. So just to draw an angle. Okay. So ABC according to the question, I'll give name given A, B, C. Now what is the next step? With the B as a center, draw an arc. Okay, what is the next step? With these two centers, just to check it is more than half only of this arc length. So here again from this center I am drawing. Here also I am keeping this. So two arcs we are intersecting at one point we are getting. Now with the help of the scale you can join this intersecting point. That will be the angle bisector ray. This ray will be bisected the angle. I think the point is clear to you. So BF is here. So D here and E here. I repeated 2 times. Now you understood this one. Now how to do the justification? Once again, a diagram construction we have to see. Angle ABC is given with the vertex angle, that is angle measurement is angle B only. With this we are drawing the arc, convenient radius. You will get 2 points. With that 2 points and the more than half of D, we are drawing 2 arcs that will intersect at F and join it. Now let us see the justification. So now the justification, I already written the steps, I'll explain. You have to join EF. This line to be joined, I'll make a dotted line for you. Similarly, DF. Right? So I'll write here, join EF and DF. Now we are considering the triangle BEF and BDF. Which are the triangle? Either of the side of the bisector. BEF and BDF. BE equal to BD. See, with the B as a center we have drawn the arc. So BE and as well as BD as a radius only. So BE equal to BD radii. And similarly, EF and DF are also equal to radii. See, E and D, we have drawn the semicircle, means arc of the circles here. So here it is intersecting. So EF, what is the distance we have taken? The same way DF also we have taken. So EF and DF are also equal. That is the second side. Now BF is common. The first one is BE equal to BD. Second one is EF equal to DF. Third one is BF. So we got all the three sides. Therefore, triangle BEF congruent to triangle BDF, SSS criteria. Now what about angle? Angle EBF equal to angle DBF. See, angle EBF equal to angle DBF. That means it is bisecting, equally divided. Angle 1 and 2 are equal. So what is the total angle ABC? See that one. What is the total angle ABC? It is equal to, it is divided into two. Which are they? Angle EBF plus angle FBC. That is only ABC. Instead of EBF, I can write as ABF plus FBC. Right? So we got ABF. ABF means angle 1 and FBC means angle 2. By CPCT, these two angles are equal. So angle ABC we can write as 2 times of angle EBF, or ABF we can write similarly 2 times of FBC. Or EBF can be written as half of ABC, FBC can be written as half of ABC. That means it's bisected equally. We got angle bisector property here, we have proved here. So for that we have to join. Justification, if it is asked in the question, then only you should do, right? Otherwise you can do the steps of construction and the diagram. So this is the first question. We have learned now just the bisector of a given angle now. Construct an angle 90 degree and justify the constructions. Draw a ray OP. So we have to draw a ray OP. With O as a center and a convenient radius, draw an arc which intersect OP at O. So we will draw a semicircle here, which is cutting OP at A. Right? Now with A as a center, now we cannot change the radius. That is the important point here. With A as a center, with the same radius what we have taken, we will draw another arc B. Again B as a center with the same radius, you cut one more arc, that is C. So read the steps. With the O as center and a convenient radius, draw an arc which intersect OP at A. That means this semicircle we have drawn which cut OP at A. Now what is the next step? With A as center and the same radius, see the same radius, draw an arc which intersect the previous arc at B. Now what is the next step? We change the center to B. B as a center and the same radius, draw an arc which cut at C. Now taking B and C as a center, draw an arc of equal radius. So with B will keep and C will keep, you will get 2 arc, and join this one At Q we can write, so angle POQ equal to 90 degree. Now we will see the justification after our real construction. Now you got the steps. Now what is the steps? Draw OP. Next, with O as a center, draw a semicircle which cut OP at A. With A as a center, draw an arc which cut the previous arc at B. With B as center, we will get one more arc at intersecting at C. B and C at centers, we are getting the same radius which is cutting at Q only. Now let us see the steps. Then angle POQ equal to 90 degree. A ray OP is given. Now what is the next step? With O as a center, we have to draw a semicircle. Okay. So according to the question, I already told that we are not changing the radius. A I am writing here. Right. Now once again, A as a center, what we should do? We have to cut this arc at B. Again you keep one more time and cut another arc. So respectively, while keeping the compass, don't change the radius for 90 degree. That is the important steps. So B and C. Now B and C as a center. First we had done A as a center, now B as a center, right? Correctly keep that one. B as a center, draw an arc with the same radius. Again one more arc. So we got here intersecting point we have taken as a Q only. Now I'll join this one. Okay. Q I'll mark here. POQ is 90 degree. Once again I'll draw the steps. Lower class you might have studied this one. What are the steps here? We have to draw an arc is given to, any ray is given to you. Any ray you can take. So I'll draw the ray now. O and P. What is the next step? With the O as a center, draw a semicircle. Okay. Now this point I am not marking. See that I am not changing the radius. What I should do? Keeping here one first arc, then one more arc. Again this has a center only, so you can continue here like this. Okay. So now just complete the diagram. So you'll get an angle POQ equal to 90 degree. So 2 times I already done. You learned now how to do the construction and all. So just I'll complete. So what are the names? P, O, Q here. Here A, B, C. Right? These are the steps we have done. Now how to do the justification. So join OB, AB. So I'm joining OB here. Okay. Next AB also I have joined. Now if OB and AB I have joined here. B is here only. Okay. This is same arc only we are considered. So what is the radius OA? That is same for OB also. So OA equal to OB as well as AB. So this is an equilateral triangle. Understood? Angle OBA is an equilateral triangle. So already we know that if it is a equilateral triangle, what you can say about angle AOB? AOB equal to 60 degree. In the same way, we already explained you that we are not changing the radius anywhere in the construction of 90. So the same radius we are keeping, right? So if I joined OC and BC, another equilateral triangle you are getting. Join OC and BC, angle BOC equal to 60 also. So angle BOC equal to 60 degree. So this is already 60 degree and this angle is also 60 degree. Now we have already proved angle bisector concept. What is that concept? Let me join CQ and again BQ. Okay, so by joining CQ and BQ, we are getting OCQ is congruent to OBQ. Right? Here I have written the order QCO only. QCO congruent to QBO. What are the concept? OC equal to OB, CQ equal to BQ and OQ equal to OQ common. The same concept we have learned in the angle bisector property. After that what we can say that each angle is bisected. So angle COQ equal to angle BOQ by CPCT. So what is COQ? Angle COQ equal to half into 60. We have proved that half of BOC only. So it is equal to 30 degree. That means here we got 60 and this angle we got 30. So what is the total angle now? 60 plus 30 equal to 90 degree. So we got the justification. Little bit difficult if you feel little bit. So don't consider this is a difficult one. Equilateral triangle concept only we have used here 60 degree. Again the second step also 60 degree. Then bisector property. So we got 30 degree. So total angle is 30 degree. In case the justification is asked in the question, then only do this part. So we can do the next question. So with this today's class I am winding up. Thank you.